Okay, hi everybody. My name is Vindhya Joseph, and I'm with the WinSE base test team. I'm responsible for testing the Windows 2000 kernel and the XP kernel and Server 2003 and so on when it happens. So I'll be talking today mainly about globalization testing and why we should be doing globalization testing, what is it, and how do we do it, and what are the typical problems we see during globalization testing. So, what is globalization? Basically, Windows 2000 has just a single code base, and all the different language versions of Windows 2000 that come out, like the Japanese version, the German version, everything is built from the same code base. So you have one single binary, and that is localized. All the resource strings, everything that's related to the user interface, everything is localized, and then you come up with a localized version of the operating system. And the main intention of globalization is to be able to support the different languages that we want to support. So there are some important concepts that we need to first understand in order to understand globalization testing itself. The very first concept is that of a locale. A locale is basically a set of user preferences pertaining to the user's language, sub-language, his location, date and time representation, and all that that's stored in the system. So every Windows system has two locales. One is called a system locale, and the other is the user locale. And the user locale is specific to each user that's present on the system. So there'll be one system locale and multiple user locales. The second concept to understand is that of a code page. A code page is something like an alphabet. It's a character set which defines all the characters, numbers, any punctuations, any other symbols, and special characters that pertain to a certain language. Now these characters, there are two different kinds of code pages that are most popular. The first one is the OEM code page. This was what was present in the MS-DOS days, and this code page had built-in hardware support for display characters, and it had only 128 characters, basically all the English alphabets and nothing else. Now this was not enough when we started thinking of supporting the European languages for Windows 2000. Now for that, we came up with the ANSI code page. Now with the ANSI code page, you can install different fonts. You can have support for slightly extended support than the English character set itself, because you have the English character set and you have some more space left over for, say, some of the European characters. So now you have the code pages, the OEM and the ANSI code pages, and now you need to map each of the characters in the code page to a numeric value, because the processor obviously understands only numeric values. That process is called encoding. And the different kinds of encoding that we have today are ASCII, extended ASCII, DBCS or MBCS, and Unicode. ASCII is a single byte encoding system where every character is represented by a byte, but the obvious flaw of this encoding system is that you can only have 128 characters represented. Now extended ASCII included most of the English characters plus a few more characters which were mostly for the Eastern European languages. Then came the Far East languages. With Far East there were so many more characters than whatever we had till then, and one byte was not enough to represent all these characters. So it was decided that for the ASCII character set we'll use 1 byte, and for anything that goes beyond that we'll use 2 bytes. Now that is the MBCS encoding system. But then the problem is that we have this mishmash of stuff where some of the characters are represented by single bytes, some by double bytes, so there's a lot of confusion. So we came up with the Unicode encoding system where all characters are represented by 2 bytes. Now, in globalization testing, what we need to do is to make sure that this supposedly world-ready code in Windows 2000 can actually handle all input from different languages and not break the functionality. It should be able to handle the input in any language that it's supposed to support, and it should also be able to support output and do all the functionality, data conversions, everything that's supposed to do. So the way to do globalization testing would be to install the language pack for the language that you're testing and set the system locale and the user locale and start using whatever characters are pertaining to that particular system locale. So the components that are most susceptible to globalization problems are those that we kind of tend to focus on when we do globalization testing. So the components most susceptible would be anything that supports ANSI or calls ANSI APIs, components which have a extensive string handling, a whole lot of edit controls that take in user input, components which use files for data storage and data exchange. All these, like for example, if you have a component which uses files for data storage, if that particular component is on the German version of the system, the files would have data in German. And now if that file, for example, needs to be ported over to another system which is in Japanese, you have the data in German in the file and you need to convert it into Japanese to be interpreted to the user of that Japanese system. So such components are those that we need to focus on when doing globalization testing. Now to do globalization testing, the things we need to do are to decide the priority of the components, select which build you want to test it on, prepare your tests, set the environments, and then start executing your tests. To decide the priority of the components, these are kind of loose guidelines given to decide what components are high in priority. The highest priority is given to components that are inherited from the Win9x code base, because Unicode support was not very extensively used in that code base. So if components have been inherited from the Win9x code base, you can be pretty much sure that there might not be enough Unicode support. Components that use ANSI or call ANSI APIs, components using strings, components again using files for data storage and exchange. And the type of build that you use for globalization testing. So if you want complete 100% coverage on globalization, what you need to do is basically go through all the 28 different languages that we support, go through all the system locales and input data in all the different languages that we support and make sure that everything works. But then that's not possible, right? 28 different languages and going through all your tests, it would take a long time. So the most optimal set of languages that you can use in order to get a near complete set of testing is a combination of Japanese, German, and English, because English covers all the ASCII character set, German covers most of the East European, and Japanese covers the Far East. And you need to run all your manual tests, you need to run all automatic tests, automated tests, and all your API tests. And whenever your test programs handle strings, you should enable the test program themselves to be able to use Unicode strings and ANSI strings, because if your test program itself cannot handle Unicode strings, it's probably not going to be able to call the Unicode version of the APIs. Now, again, the way to prepare your test is to make sure that your test can handle Unicode strings. Whatever test input data is given should be characters in the Unicode range, and what we need to look for is that when we give data to the test and the test is executing, all that all the characters in the Unicode range should work properly. There should be no errors. If it's a non-Unicode system locale, then if you take problematic characters of the system locale, for example, if there are some special characters, say in Thai or in Arabic, those characters work properly without any problems. So the global test data would be like a mixture of, it should not be just English or just German or just Japanese. So if you say have a machine with the German language pack and the Japanese language pack installed, you should give it a mixture of Japanese and German characters, because both the language packs are present, the system can interpret both language characters. So you should give input in a mixture of characters. You should give input in characters that match the system locale, do not match the problematic characters in that particular locale. Come up with a mix and match of input data that needs to be given to the test. And to start globalization testing, once you have prepared all your tests, make sure that it supports Unicode, you have all your test data in this mixture of input characters. Now you need to prepare your system to run your globalization test. For that, you need to install the language pack whichever language pack you're planning to test, which the most optimal case would be German and Japanese, and then set the system locale to either Japanese or German, and then you need to start running your tests. To install the language pack, you can go to Control Panel, Regional Options, and you can install it from there. Now these are a couple of sample globalization test environments. So this is in a client-server test environment where all the machines on the network have the system locale as German, and all machines have both Japanese and German language packs installed, which means that the machines can interpret both Japanese and German characters, and all the computer and domain names are in German, and the data that is given for the testing purpose consists of a mixture of Japanese and German characters. So for example, if you have, say, a client which is trying to connect to the server, and the client is inputting data in, say, Japanese, and the server is configured for German, then it should be able to interpret the data correctly. The main purpose of this environment would be to catch all the problems caused by non-Unicode components, and also wrong Unicode conversions that are done in the core OS itself. The second sample environment is pretty much the same as the previous one. The only difference here is that the system locale, instead of being German, is Japanese, and the computer and domain names are in Japanese. And again, the input characters need to be a combination of Japanese and German, and the same thing to look for is that there shouldn't be any problems when converting to DBCS, and no OEM and ANSI code page confusions. So when you have the German German locale, system locale, what happens is that German code page is what is used to do all the conversions. When you have the Japanese code page, when you have the Japanese system locale, the Japanese code page is what is used to do all the conversions. So if whatever input data that comes in, it compares it to the code page that it has, and then it says, okay, this is the string that I got. So depending on the system locale that you have, the code page use is different. So the main thing we are looking for here is that if we switch between the Japanese and German locales, because of the difference in the code pages, there shouldn't be any errors in the way data is handled. Now your tests are set up, now your environment has been set up, now you need to run your test with the global data that you created and ensure that all the functionality of your component works upon input of these mixed characters, using these characters, and wherever the system refers to these characters. So the most typical globalization bugs that are found are that the component, say, is non-Unicode, it's using ANSI APIs. In that case, if you pass it some German characters or Far East characters, it will not be using the correct version of the API, so it will not be able to interpret the characters properly, the buffer lengths will not be enough, all those problems. Then you could have hard-coded strings within the component. Hard-coded strings would mean that you're not able to localize the product. For example, if you have a string that is hard-coded in English, when you try to localize the product to German, the string stays in English because all the localization is done for the strings in the resource DLLs, and this string, because it is hard-coded and it's not in the resource DLL, doesn't get localized into whatever language you're trying to localize it to. The other typical problem would be that when you're computing buffer sizes or string lengths or validating any input data, if you do not consider Unicode characters, your buffer lengths, your input sizes are all different from the ASCII lengths. And the last kind are the localizability bugs, which mainly are something like hard-coded strings, or you could have for example, in the UI you could have button sizes or edit control sizes which are fixed, and when you localize it, if the text is much longer than the size that's been fixed, the text would overflow and the UI would look bad. Typical display problems would be, for example, if it's not able to find the corresponding match in its code page, you'll find question marks, if the language pack is not installed correctly and it doesn't find the font, then it will again display boxes, or the wrong character set could be used, and the wrong, in that case, the wrong data is displayed instead of the correct data being displayed. So these are the typical display problems you'd come across. Well, that was a pretty short presentation, and that's what I had on globalization. More information can be found in these web pages if you require. Yep.
There's a way in which you mentioned install the language packs for testing the German or Japanese machine. But we can also install the OS in that language. What is the difference? If we straight away install a German, say, home OS, German Windows XP OS directly, instead of installing the language pack later, is there a difference?
Yeah, so the question is there a difference between installing a language pack versus using the localized build in that particular language? So when you install a language pack, what happens is that the OS still is in English, and all you have installed is support for that language. You now allow the operating system can now understand, read and write characters in that particular language. Whereas when you are installing the localized build of the language of the operating system, all the UI resources, everything has already been localized into that particular language, right? So now even though you install the language pack, you can input data in two languages now: the native language of the OS and whatever language pack you have installed. So there are two languages in which you can install input data. So a component can receive input data in two different languages, and that is different from a localized version where it receives input only in one language.
But even if you install the German OS, and if you do a shift alt, the keyboard display changes into English, and we can still input data in English.
It's only the keyboard, the layout is changed because the locale gets set to the English locale, and that's all. Nothing else changes in that case.
Input data into language.
Yeah, so the other difference is that so when you're installing language pack and doing your testing, you're basically testing in order to make sure that localization of that OS is an easy process and you'll not find many bugs after you've localized. So if you have already done all your testing with the German language pack installed, then localization into German is only a matter of converting all the English strings into German. You've already done all the testing to make sure that the characters are handled correctly and all the Unicode related problems are discovered and everything is done. So you're supposed to do both kinds of testing. The globalization testing is done prior to localized or localization testing. So globalization testing is like a precursor to localization testing. You make sure that all the problems in the underlying code base are discovered, and then you just localize it into German and do a test pass to make sure that, okay, now in German everything works fine.
Since you're doing functionality testing, would your test scripts vary based on the language you're testing it on?
If your test scripts take input data, then the input data would vary. But other than that, the functionality testing remains the same.
We have to install input method editor for forest languages. Doesn't setting the locale to that particular language is enough for typing the characters in that language?
So the question is that if you set the locale to a particular, say, Far East language, will the input method editor for that language be available? So when you install the language pack, it should install the input method editor for that particular language also.
Particularly for Far East languages, we separately have to install global IME apart from the language pack.
Yes, so setting the locale only changes your input preferences. So when you set the locale, and it changes the keyboard layout and all that, but for Far East languages you cannot use the English keyboard, so that is the reason why you need to install the input method editor for Far East languages. But if it is say German, if you just install the language pack, you can use your own keyboard. It just changes the language and the layout, and you can continue to use it. Yep.
How do you ensure any piece of code is fully globalizable?
Fully globalizable. So the question is, how do you ensure any piece of code is fully globalizable? Again, the main thing is make sure that it's using Unicode APIs and test on this combination of German and Japanese language packs. Make sure that you give it can handle all kinds of input data, whether it is German or Japanese or English combinations. And if it has any UI, make sure that there are no hard-coded strings that are being displayed. So those are the kind of the guidelines described in this presentation, which you go through in order to make sure it's globalizable.
How is UTF-8 encoding different from MBCS encoding?
The question was, how is UTF-8 encoding different from MBCS? I don't exactly know what's the difference. I don't know the difference. Yep.
Suppose I have one exe.exe, right? Now I want to make sure that it is properly localized for globalization. So I used one tool from Microsoft. I don't know the tool name at this moment. But what it does, it opens that exe and see the resource header there and put 40% extra character there. And we run that exe again. So are we going to use such tool in this test?
No, for this testing we do not use tools like that. The tools we use are tools that will generate input test data for you. Tools that will generate test data of different varying lengths and different languages and all that. We do not use any tools which just open the resource and change the data on that. Any other questions?
In a particular milestone, how frequently we are supposed to run the test globalization?
Once per milestone?
Any milestone, SP milestone?
Yeah, that's what, once per milestone. So, yeah. So if you have a service pack release, just these are the set of like MUI testing, globalization testing. All this is done almost towards the end of the service pack release.
And what locales do this normally?
Japanese, German. Yep. Any other questions? Okay, thank you then.